Okay, so basically what I've done here is done a quick illustration of the most common type of fuel pump. Basically looks pretty much something like this. It just kind of looks like an electric motor, really. They work off, it's like a turbine pump, similar to like what you would see in like a jet engine, but for liquid. So you'd have a very fine filter, in-tank filter, which is basically just for like larger rust particles and whatnot. These generally don't need to be replaced, but they get replaced if you ever replace the pump. Your inlet spout is right at the bottom. This sits right at the very bottom of the gas tank. Then basically the electric motor, believe it or not, like the gas actually flows right through the motor as it gets pressurized, and the entire system is grounded very, very well to prevent sparks or static electricity buildup, things like that. You have a plug up here. Generally it's a 12-volt source and an outlet. So basically your fuel line that comes out of your gas tank would be connected right here, and that would go under your car, into your engine bay, and up to the fuel rail. Generally, most commonly, this should be about 40 to 45 psi coming out here. A lot of vehicles have your fuel pump basically, right? So let's say that's putting out 40 psi to your fuel rail, and some vehicles they'll have a return line. So after your engine uses the fuel it needs, it sends the fuel back, the rest of the unused fuel back into the gas tank. Well, that's good for if you put additives in your tank. It helps mix it easier. But some vehicles like Jeeps, I think Jeep started doing this late '95, for example, is basically they only have one line going up to the engine to the fuel rail. There is no return line. Basically how they keep the pressure, which is about 40 to 45 psi, is with a little pressure regulator. Kind of did a decent illustration on that ish. Basically that's like a little plastic piece that's on the outlet. So when your fuel pressure builds up, there's a little check ball in there that's held down by a spring, and when your pressure builds up, it pushes that check ball up, and then the fuel vents through the little spout, which would be right there. So there's your check ball, there's a spring, there's a spout. So then your pump continuously runs. You have continuous pressure in this line, and the rest of it just continues to spew back out into the tank, which again will also help mix additives and things like that. Most fuel additives are actually useless though, to be completely honest, but the very odd few do work. Here's a fuel pump that's not seen very often anymore. These were used mainly on carbureted vehicles that really don't require fuel pressure, just a way to get gas from the tank to the carburetor. And it's what's called a diaphragm pump. Basically consisted of this lever, which went into the block and had its own dedicated lobe on the camshaft. So when this turned and came up, it would push this lever, pivot here, so it went like this, pivoted on a rod here, push down this connecting rod, which is connected to a diaphragm, and it would push or pull the diaphragm up or down, creating suction and then pressure. Not much pressure, of course. So your fuel would go in. Sometimes some of these used like a flap style of one-way valves, and then it would come out this way. Some of them used basically check balls, which is like a ball bearing in a spring. There are a couple different styles, but basically they were all the exact same principle and idea. Oops. So you had a seal about here to protect this diaphragm from oils and things like that from the engine, because basically it was completely open right here because these pivot points needed to stay lubricated. So that basically sucked fuel from your tank, filled up in here, and then when this cam lobe would come up, it would push the diaphragm down, push the fuel out, and that would go up to a carburetor. And if I had it my way, it would be a 4-barrel. But some are 1-barrel, 2-barrel, 4-barrel, 4-cylinder, 6-cylinder, 8 cylinders. Basically very common on old carbureted vehicles. Here's a very quick illustration of a fuel injector. It's actually a little poor. I apologize for that. Basically, here's the inlet here. So this, your fuel rail would be sitting along the top like this. Your plug for the voltage signal or whatever would plug in right here. Basically, you have a plunger, little valve on the end. Basically, it's like an arrow, just kind of plugs this passageway. So your fuel would come in here, fill up in this reservoir. Remember, it's about 40 to 45 psi on average. When this valve would open, due to electromagnetic current, basically it works as a solenoid, would pull this plunger up, pulls this arrow looking thing away from that port, and allows the fuel to spray through fine screens and then a fine plate right at the end, which atomizes the fuel, turns it into a very fine mist. This right here is supposed to be an O-ring. It turned out awfully shitty along with the top there. So basically you'd have electromagnet wrapped right around it, and then your plunger in the center there, and it basically, that's really all it is a solenoid. It's a valve solenoid. Really, it's pretty much as simple as that. It pretty well would look like that too. Obviously you wouldn't see all this junk. There are different types of fuel injectors though. Still really all work on the same principle. There would be a return spring in here to keep this closed while there's no current running through it. But that's pretty well the gist of it. I wish it wasn't winter and I could actually go outside and demonstrate everything for you guys.